Here's the setup for the electron transport chain relay race. At this end you can see the ATP synthase machine with a little reminder, 3 protons makes 1 ATP. Underneath we've got some little objects that represent the phosphates. Outside are the ADPs waiting to get the third phosphate put on. I used Legos. You don't have to. You can use anything you have on hand, marshmallows on toothpicks, whatever you want to use. You can see the little water molecules waiting and the oxygen outside the third ion pump. And here you can see the dried lima beans that represent the protons and the dried kidney beans that are going to represent the electrons. And make sure you have the second shuttle is marked 2 electrons, that's the ubiquinone, and make sure the shuttle outside the second pump has 1 marked in. That'll be a reminder to the players, because it's easy to forget while you're playing how many go in each shuttle. And just a final little note, you can see I've put some tape down to hold the pumps in place. If you have a playing surface that you can tape the ion pumps to, the game will go much more smoothly, because the paper pumps have a tendency to get knocked over very easily. So if you can tape them down, your game will go much more smoothly. Okay, this is how you play the game. You start with 2 electrons in the NADH shuttle, bring them over to the first pump, and you're allowed to put both of them through at the same time, because the first shuttle can take 2 electrons. So you can send them both through, and as you feed an electron through, that lets you bring a proton up. You can slide this to the next pump. Now this shuttle can only hold 1, so you're going to have to shuttle each of these independently. Put 1 through, bring the proton up, slide it to the third pump. Now when it comes out this side, you're going to want to put it into one of the hydrogen containers there, and then bring the proton up. And then you can also add a proton here, because an electron and a proton make a hydrogen atom. So now that hydrogen atom is ready to go. Now we're going to come back, take our shuttle back over to the second pump, and do the same for this. Feed it through, bring a proton up over here. Now we're going to finish this one off. We're going to put a proton there, so we've got both hydrogens. Don't forget to bring a proton up, and we can add an oxygen, and that one's going to be ready to sail away. Now we need to make a second one, so we're going to go all the way back to the beginning and do the whole thing again. 2 electrons in NADH, bring it over, feed them through, bring up 2 protons, slide it over. Remember, only 1 can go through at a time here. 1, bring a proton up, slide it over, feed the electron through. Don't forget to bring a proton up and put a proton in here. Go back and get this last electron, bring a proton up, slide it over, get it into this last hole. So there we've got our oxygen made. Don't forget to bring a proton up. Now these waters can just sail away now. They're going to be expelled as waste products, basically. Now we can make our ATPs. 3 protons is 1 ATP. We gather up our protons. Well, you can gather them all at once or just take them 3 at a time. I think I'll just take 3 at a time. Take these 3, put them down through, and that lets me get out 1 phosphate, snap it on. Go back, I'll pick this one up and 2 more. Come back over the ATP machine. And if you want to make it really technically accurate, you can even give this a little twist. In real life, the machine actually does a little twist on the bottom. Pull out another phosphate and make another ATP. How many can I make? I can make another one. There's 3. Put them through. Or you can also, if you don't want them to fall through, you can drop them kind of into the outside of the cup there. Get another phosphate. Make a 3rd ATP. And looks like we can make 1 more. The last 3. feed them through the machine. Give it a little twist, add a little realism to it. Get out another phosphate. And that's the end, because we've made 4 ATPs, gotten rid of our waters, and finished up all our electrons.